And all of this that I'm about to do with you is on the classroom on Google Classroom. So you don't need to, you can screenshot it if you want. I will wait if you want to take screenshots, but you don't actually need to. It is actually all uploaded for you. All right, so there are 4 types of graphs that we have learned in grade 11. In grade 9 and grade 10, we focus in grade 9, we focus on straight lines, and then 10, 11, 12, we focus, 10, 11 really, we focus on parabolas, hyperbolas, and exponentials. Now, guys, understanding just the basics of these functions is going to help immensely when you go and start answering questions on these graphs. So your first function that we're going to have a look at is our straight line function. Now, your straight line function, again, you've been doing this since grade 9, some of you even grade 8. So nothing here should be new. So I'm going to run through this one relatively quickly, and then I'll focus a little more on the other 3. But again, basics that we need to know. It's also really important that you understand your straight line graphs because it can come up in paper 2 in analytical geometry. So talking about angles of inclination, talking about parallel and perpendicular lines, all of those are geometric concepts, but bring in straight line knowledge. So it can come up there. And we also know that straight lines can obviously come up in our calculus questions when it comes to tangents to a curve, when it comes to second derivative graphs, etc., etc. So straight lines pop up pretty much everywhere, and so it is important that we know how to deal with them. All right, so there's 2 important parts or 2 important features of your straight line graph. The first important feature that we have is your M value. Does anyone remember what M represents on your straight line? Nice, Rato. Okay, good. So M is our gradient. Nice, guys. Owami Kani, very, very nice. Well done. Nice. Right, so this is our gradient. The gradient is the slope of your curve, and very basically, if M is positive, it's going to increase from left to right. If M is negative, it's going to decrease from left to right. We can see that in these little pictures over here. So that is your M value. This is where parallel and perpendicular lines come in. I should have put this in and I didn't, so that's my bad. All right, so parallel lines, does anyone remember what the relationship is between the gradients of lines that are parallel? Nice. Leila Owami, very nice. Label, well done. Larato, nice. Good. So parallel lines have the same gradient or equal gradients. So if you are asked to determine the equation of a line parallel to another, if you have the gradient of your first line, you automatically have the gradient of your second line. Right, so that's parallel lines. The other type of sort of line relationship that we look at are perpendicular lines. Does anyone remember the relationship between perpendicular lines and their gradient? Nice, Leila. Perpendicular liner. Right, so exactly as Leila's put there, the gradient of one line times the gradient of the second line, if that product is -1, those lines are perpendicular to each other. So when you are trying to find a gradient of a line perpendicular to, you can use this little rule over here. Now, that's not given to you ever. That's just something you need to know. But basically, perpendicular lines, the product of the gradients is -1. All right, so that's to do with gradient. In terms of your C value, C dictates or C determines for us our y-intercept. So if C is positive, our y-intercept is positive. So this would be a positive C over here. If C is negative, we have a negative y-intercept. Straightforward, there we go. Alrighty, your domain and range for a straight line, because it just keeps going in both directions, it's just element of real. And remember, even though I've said for plotting a straight line function, any graph, if you want the x-intercept, you need to make y equals 0. If you want the y-intercept, you need to make x equals 0. That is true for any function that you work with. Right, the only other thing I want to say about straight lines, and this is going to be important when we get to things like our hyperbolas and our exponentials, is the idea of vertical and horizontal lines. All right, so a vertical line is one that goes straight up or down, is parallel to your y-axis. So this is a vertical line. That's not how you spell vertical, so let's try that again. A vertical line has a gradient that is undefined, because remember, gradient is change in y over change in x. In this case, there is no change in x. That x value is constant, so the change in x would be 0, hence it's undefined. Now, if, let's say, for example, this cut your x-axis at 2, the equation of this line is x equals 2. So a vertical line will always have an equation that is x equals wherever it cuts your x-axis. A horizontal line is then parallel to your y-axis. Getting there very slowly. So let's say something like this is parallel to your, I don't know what I said anymore, so I'm going to say those words again. A horizontal line is parallel to your x-axis. I can't remember if I said x or y. In this case, your gradient is equal to 0 because there is a change in x, but there's no change in y. And a horizontal line is always given by the equation y equals wherever it cuts your y-axis. So if this cut my y-axis, say, for example, at -3, my equation would be y is equal to -3. Okay, that is always the case for vertical and horizontal lines. And this is particularly important when we get to asymptotes. Asymptotes are vertical, horizontal lines that our graph will approach but never touch. And those exist with exponentials, hyperbolas, and if we move into paper 2, trig graphs, the tan graph. Right, so asymptotes very important, and they are vertical and horizontal lines. Okay, so that's a straight line. I'm just going to wait here in case you want to screenshot, just because I've added a few bits of information to this. And then we'll have a quick look at parabolas. And again, guys, shout if you have questions. All right, so our parabola, let's make this a tidbit smaller because there's a fair amount going on here. This equation that I've put up here is not actually the standard form. This is just one of the more useful forms of our parabola. The standard form of your parabola, and remember, standard form is different per function, but standard form is y is equal to ax squared plus bx plus c. I talk about it a little bit later on, so don't stress. But that is the standard form of your parabola. Right, your parabola, the a value tells you whether or not you have a happy or sad parabola. So if a is positive, you have a happy parabola. If a is negative, a sad parabola. P, so in this format of our parabola that I've given you here, we get given, or we can find the turning point. So if this p value is positive, so for example, x plus p, you have shifted to the left. If p is negative, so x minus p, you have shifted to the right. So that is a new concept that you learn in grade 11. And then obviously your q value is a shift up or down. So if q is positive, shift up, q is negative, shift down. It's these left and right shifts that are not the problem, but are the ones that often catch us out. And that's because of the fact that logic kind of says to us, if it's a negative value, it should go left. If it's a positive value, it should go right. But that's not the case. It's actually the opposite. So again, if you have an expression of x plus p, you go left. X minus p, you go right. So it kind of goes opposite to what we would logically think it is. Right, when it comes to the domain and range of your functions, the domain of your parabola is x element real, because remember, those arms just keep going out. Your range, however, depends very much on your turning point, which is what I've kind of got at the bottom here. But what you can take away from this is range is dependent on the y value of your turning point. If your parabola is a happy parabola, so like we've got over here, your range is greater than the y value of your turning point. If you've got a sad parabola like we have over here, it would be less than your turning point because it goes down. We'll have a look at some examples in a second. Okay, again, x and y intercepts, it's the same as it always has been, but what I want to jump to is this situation down at the bottom. We have three forms of our parabola equation that we can use. So the form that I gave you initially, that a times x minus p squared plus q, that is the turning point form. The p and the q is your turning point. So if you've been given the turning point, you can automatically chuck it into that formula, and you know two of your three unknowns. You know p, you know q, and you can just find a. The second form is your x-intercept form. This should look somewhat familiar from cubics. So cubics would just be a third bracket, but this is your x-intercept form. So if you were given the x-intercepts of your parabola, you could chuck it in and you've got those two brackets. And then obviously the final one is your standard form. Each of them give you something slightly different. It depends what it is you're trying to find. And you would only have to put it in a specific form if I ask you. So if I said determine the equation of the parabola in standard form or in turning point form or whatever, then you would have to give it in that form. But otherwise, we really don't care. We will mark you right depending on what you give us. Right, the last little thing that you need to take note of is the fact that from the standard form as it is actually only gives us one piece of information. It gives us the y-intercept. But from your standard form, using a and b, you can determine the x coordinate of your turning point using this little formula minus b over 2a. So this is a formula that, again, you're not given. You need to remember it. But you can find the x coordinate of your turning point to get the x. No, you can find the x coordinate of your turning point using minus b over 2a. And then you just substitute that back to get your y coordinate. So that's a very useful little formula to remember for yourself, particularly when you've been given a parabola in standard form. Right, I'm going to move on. So if you do want to take a screenshot of this, you can. Again, all on Google Classroom, and I haven't actually added anything new here. Okay, and then we've got our hyperbolas and exponentials. Now, exponentials will be tested more with the inverse function, so we'll chat about those exponentials a little bit more again on Wednesday, but your hyperbolas are the ones with two arms in different quadrants. So again, the a value, whether it's positive or negative, determines which quadrants your graph will sit in. If a is positive, you're in quadrant 1 and quadrant 3. If a is negative, you're in quadrant 2 and quadrant 4. We know that there are asymptotes involved. Depending on whether you shift left or right, you will have a vertical asymptote, and depending on whether you shift up or down, a horizontal asymptote. What's also really important with these hyperbolas is this idea of an axis of symmetry. So we do get axes of symmetry with parabolas through the turning point, but axes of symmetry also exist with hyperbolas. Now these axes of symmetry shift with your graph. So they will shift left and right with the actual hyperbola. And so that's something that we need to bear in mind if we are asked to find the equations of these axes of symmetry. Now, another really important point to remember is that your axis of symmetry will always pass through the point of intersection between your asymptotes. So if you have a look at this graph here on the right, those axes of symmetry pass through where your asymptotes are. So at PQ, you find a coordinate on your axes of symmetry. And that's really useful because you can then substitute in that point and you can go ahead and get the equations of your axes of symmetry. All right, everything else here, very much straightforward, nothing too tricky. The only thing, again, I'm going to point out is this idea of domain and range. Your graph exists everywhere except for the asymptotes. So these situations here, sorry, this should be a Y. So these restrictions that we have here relate to the asymptotes, because we know that a graph will never actually exist at the X value or the Y value of your asymptote. But everything else, very much straightforward. You find the X-intercept the same, you find the Y-intercept the same, and that's that. Okay, again, I'm just going to wait for like a second or two, and then we'll have a look at exponentials, and then we'll get into some questions. Finally. Right, so your exponential function, like I say, you'll deal with a little bit more, or we will deal with it more on Wednesday when we start talking about inverses, because that's often where the inverse function is tested with exponentials and log graphs. But your exponential graph, personally, what I would learn in terms of what my graph would look like is what effect A has on your graph and what effect Q has on your graph. Okay, so I would learn that if A is negative, my graph sits below my asymptote. If A is positive, it sits above my asymptote. I have put the effect of B here for you because I know some people like to know what effect B has, and that is absolutely fine. B, or the value of B, so your base, will determine whether or not your graph increases or decreases from left to right. But the reason I'm saying don't stress about B is because it's a fair amount of information to learn. But I put it there if you want to know, it's there for you. I'm also saying don't stress about it because if you're having to say, for example, sketch a graph, you're going to plot points and you're going to eventually see what the shape is anyways. But again, if you want to learn what effect B has on your graph, there it is. You don't have to stress about it, but it is there if you want to know. For an exponential function, we only have one asymptote. So you can see here it's a horizontal asymptote, and that horizontal asymptote is determined by Q. So whatever this Q value is, whatever the shift up or down is, that will be your horizontal asymptote. That horizontal asymptote also then has an effect on your range. So if your graph sits above the asymptote, greater than, below, less than. But that's pretty much it when it comes to exponentials. There's no axes of symmetry, lines of symmetry, nothing like that. But we do deal with them a lot more when we get to inverse functions. And you'll see that on Wednesday. Right, again, I'll wait in case you want a screenshot. We're going to get into some questions. Right, now again, if you go through enough past papers, you're going to start to see a pattern to how these questions are asked. So these questions are generally question 5, 6, or 5, 6. There's usually 2 to 3 functions questions. So it might be 4, 5, 6, and it's generally 4, 5, 6. And you're going to see again as you go through, it's pretty clear pattern that exists. So what often happens in the paper is that the first question on functions will be just a basic hyperbola question. When I say basic hyperbola question, I mean given, and they give you the equation. Write down the asymptotes. Write down or determine your x-intercept, your y-intercept, range, domain, stuff like that. Basics. And generally in that question, they ask you to sketch. So that will be the question where they ask you to sketch the graph. And like I say, 90 to 95% of the time, that first question is based on a hyperbola. The next question will be a more complex question. This will be a combination of graphs. Again, 80-90% of the time, it is a parabola and a straight line. I'm not saying always. You're going to see now in a second that I said you're going to see now in a second. I hope I put it in, but if not, I think it was a 2017 paper. I think it was a parabola and a hyperbola. So it's not necessarily always parabola and straight line, but 90 to 95% of the time, those are the two functions that we combine. However, what you need to be prepared for is working with two functions at the same time, whatever those functions may be. If there is an additional question, and usually there is, that will then be where the inverse functions come in. And so that will be your question, what are we on? 6, 7. And that's what we'll have a look at on Wednesday. So what we're going to have a look at now is just those sort of grade 11 level questions. So this is an example of just a straightforward hyperbola question. I say straightforward, this actually was quite a tricky one. This was from 2 years ago trial exams. And I'll tell you why it's a tricky one in a second. But this is a grade 11, like typical grade 11 type of question. Like I say, it's usually just a question that's yay big, and it gives you the equation, it asks you a bunch of questions, and that's pretty much it. But 9 times out of 10, it's a hyperbola. All right, so let's read what we have. Remember, always read the information in your question. It often gives you a whole bunch of stuff that you didn't realize you needed and do. Sorry if that's a bit loud. Right, so in the diagram below, the graph of the hyperbolic function f of x is equal to x plus k divided by x plus p, where k is a constant, is drawn. So the first thing, and this is why I'm saying this was a slightly trickier one, is that the format of your hyperbola's function equation is not what we're used to. Okay, this is a slightly different format. There's a very easy way to deal with that, and we'll get to that in question E. Right, there's just a question. Ma'am, when we sketch graphs, as long as we show what the question asks, we won't lose marks if the graph is not drawn to scale. Yes. So 9 times out of 10, when they ask you to draw a graph, the question actually says sketch the graph of F, G, H, whatever. And all that then means is draw your graph, whatever the graph is, I don't know, and make sure your labels are accurate. So make sure you have labeled your asymptotes. Make sure you have correctly labeled your y-intercept. As long as those things are correctly labeled and you've actually gone and calculated them, I couldn't care less if it's not to scale. Sometimes we do give you an answer sheet, so like a set of axes where you can then draw it to scale. But if it just says sketch and you're just doing it there and then on your line paper, like you say, it does not need to be to scale, but all your labels must be correct. So you actually have to go work out your y-intercept, your x-intercept, etc., etc. But no, scale is not important. Do not waste your time trying to draw a set of axes to scale, right? The question will say sketch. We want to sketch. Okay, so like I said, this one a little bit weird because the hyperbola is not in the form that we're used to, but that's okay. We can deal with it, and I'm going to show you how to deal with it in a second. So where k is a constant, all that means is that k has no variable attached to it. A is at 1, 0, and B are the x-intercepts and y-intercepts of this graph respectively. This word respectively basically means that the order is important here. So A was mentioned first. It links with the x-intercept, which was mentioned first. B was mentioned second, links with the y-intercept, which was mentioned second. You can obviously see that on your diagram, but just so that you know what it means, respectively means go in the order. Right, it then also says that the vertical asymptote goes through the x-axis at 3. So we've got a vertical asymptote, and we know that's at 3, and this is shown to us on our diagram. Beautiful line that I've drawn there. We do know that we have a horizontal asymptote. I just don't know where that is just yet. Right, so let's get into the questions. The first question says, write down the value of P. Now we go back to the equation. P is in the denominator, and remember this expression of x plus or minus P. This represents a shift left or right. So ask yourself, what has happened to this graph? Well, this graph has shifted to the right 3 units. That expression must represent that shift left or right. So we know that a shift to the right 3 units, let's just write this down, right 3 units, would be expressed by x minus 3. Remember, it would be the opposite sign. Usually we would think, okay, minus is to the left, but it's actually the opposite when we come to horizontal shifts. So what this means is this negative 3 is my value of P. P is equal to negative 3. If you substitute that in, so x plus negative 3, you will get the expression that you want. And this is, again, why I'm saying to you, knowing the basics of your graphs and understanding how the manipulations work and what they do is so important. Because you knew that a shift to the right must be a negative in the expression x plus or minus, it's very easy to then get your value. If you had said P is equal to 3, remember, if you substitute that in, you would have x plus 3, which represents a shift to the left 3 units. This graph did not shift left 3 units. This graph shifted right 3 units. So just be very, very careful when you find the values of P. Again, guys, just if you have questions, put them in the chat or raise your hand. I'm just sort of going to go, and if you have questions, you need to ask. Question B says, determine the value of K. Now, The second you find a bit of information about your equation, put it in. So we know f of x is equal to x plus k, but now we know our denominator is x minus 3. That is information we know we have, we've determined it. All we need to find is k. Now, if you've got one variable that you don't know in the equation of your function, find a point on that graph and substitute it in. We know that a is on this hyperbola, so we're just going to substitute in a. Right? Because if it's only one variable we don't know, we just need to be able to substitute in for x and y. So 0 is equal to 1 plus k over 1 minus 3. 1 minus 3 is negative 2, so 0 is equal to 1 plus k divided by negative 2. If I divide both sides by negative 2, obviously 0 times negative 2, I'm just carrying on here, is still 0. And on the right-hand side, the negatives 2 cancel. Negative 2's cancel. So I've got 0 is equal to 1 plus k. And that therefore means that k is equal to negative 1. So again, anytime you have one unknown in your equation that you need to solve for, sub in a point that you know is on your graph, and you can solve for that unknown. Right, question C then says, calculate the coordinates of B. Now, who can tell me what is special about B? What is B to this hyperbola? Savoyo?
Oh, it's y-intercept.
Lovely. Okay. So this is your y-intercept. Which value is 0 at your y-intercept?
X is 0.
X is 0.
Yes.
Good. Okay, so x is 0 at your y-intercept. Now again, guys, this is just information that we know from grade 11. And if you don't know it, you now do. So it's not the end of the world. But having that information is super important, because now what we do is we take our equation that we've just completed. So x minus 1 over x minus 3. And we substitute in x equals 0. So 0 minus 1 over 0 minus 3 gives us a y-intercept of a third. Now, it does say coordinates of B, so write down your answer as a coordinate. Whoops, 0, a third. But now we know exactly where B exists. And so if we need to use our y-intercept, or if we need it a bit later on, it's right there. We have it. Right, question D says, determine the values of x for which x times f of x is less than or equal to 0. Right, I know these are ones that we don't particularly enjoy, so let's break down what this is actually asking us. So this is saying x times f of x must be equal to or less than 0. Now, if a value is less than 0, what is its sign? Is it positive or negative? So if something is less, nice. Okay, so this means it's actually negative. Now, guys, let's think about this. If you are multiplying two things together, two values, in order for us to get a negative product, one must be positive and one must be negative. It doesn't really matter which one's which, but you must multiply a positive and a negative. In order for something to be equal to 0, one of them must be 0. So either you can say 0 times a positive value or 0 times a negative value, but one of them should be 0. Right, and this is now quite honestly where I would take a highlighter and I would now start looking at my graph. So firstly, let's grab a color here. It's saying the x values times a graph. So x values, if we go to our set of axes, all of these x values to the right, and that's not to the right here, to the left of your y-axis, these are all negative x values. Everything to the right of your y-axis are positive x values. So that's the first thing. We've determined where x is positive and where x is negative. This f of x, remember f of x is just a fancy way of saying y. So what we're saying here are the y values of my graph. So go to your graph and look at where they're positive and where they're negative. Anything above your x-axis is positive. Anything below your x-axis is negative. So this arm here, if we go left to right, this is all positive, lovely, 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 still positive. Obviously, when it hits here, this is 0. But the second it goes past that, this is all negative. It's now below my x-axis. This other arm of my hyperbola, this is all positive. At no point does this arm go below my x-axis. And so I'm now looking for a place where the signs of x and y are different. So if we go along this arm, this is all positive until we get to 0. Sorry, hang on. This is all positive until we get to b. This is all negative in terms of x. So that's great. We've got a positive times a negative. That's going to work for me. That's going to give me the product that I want. If we now move into the next little section, which I'm just going to grab another color because this can get a little bit confusing. So if we go to this next section, this tiny little bit here of my hyperbola is still positive and x is positive. So that's not going to work, unfortunately. I don't want a positive times a positive. However, if I keep moving from this coordinate A, my hyperbola is all negative. My x value is positive. So for this little section here, again, I've got a positive times a negative. So times a negative. So this is going to work for me in terms of my product. And this is, there's no other way, or there's no like shortcut way, unfortunately, to answer these questions. You quite literally have to look at your graph and use your information. The only thing I can say to you is that oftentimes any intercepts with your axes or any points of intersection for these inequality questions are important. So you can see here that this first section is from my y-intercept, obviously all the way to negative infinity. And the second section here is from my x-intercept to my asymptote. So oftentimes intercepts with axes, asymptotes, points of intersection, those are going to be those values that you need to look out for. So if we consider this first section here, so from b to negative infinity, this would be x less than or equal to 0, because remember on your y-axis, x is equal to 0. And for this tiny little section here where your hyperbola is negative but x is positive, we have got from positive 1 to 3. Now remember, 3 is an asymptote, so we can't include 3, but we can include 1, because at 1, y is equal to 0, and it did say equal to or less than 0. And so these are the two parts or two portions of my function where I will get a negative product when multiplying together an x and a y. Now again, grade 12s, I'm not saying this is easy, right? These inequality questions are generally quite tricky, particularly when we start talking about products. But always go back to, if you want a negative product, what does that mean you're multiplying? A positive and a negative. Where is your graph positive? Where is it negative? And you can then start to sort of narrow down your options from there. Right, does this make sense? Again, I know this is a tricky question. I'm not by any means saying this is easy, but does it make sense? Oh. Nzlama? Sorry.
Ma'am, can you please repeat?
What would you like me to repeat?
Ma'am, from like where we multiply the positive and the negative for us to get the inequalities.
Okay, sorry. All right, so do you understand why it must be positive and negative?
Yes, ma'am.
Okay, cool. So let's just take off some of this. Let's just take off. Oh, so much crap. Okay, right. So everything is off. If we have a look at our y-axis, everything above x is positive, everything below x is negative, and if you look at your x-axis, everything to the left is negative, everything to the right is positive. Now I have to look at my x-axis because of that x right at the beginning of my product. We then go to our actual equation, f of x. Let's do something better. Right, so all the positive x values, I'm going to highlight in this bright green. Positive x values. All the positive y values, I'm going to highlight in this bright green. So this is positive because it sits above my x-axis, and this entire arm here is positive because, again, above my x-axis. Everything that's negative, I'm going to highlight in yellow. So this little bit of my arm here, that is all negative. So now we need to go and see what sign would x have when it corresponds to these things. Now, again, if you're not too sure where to look, always look out for points of intersection. Intercept with your axes. So B, A, let's just move this over. B, A, and then obviously your asymptote. Those are generally going to be very important points when it comes to an inequality. So if we go and have a look here, this is all positive because it's the bright green, and the x is all negative, as I've already said. So this is a solution for my product. Positive times a negative will give me a negative. So these are all the x values less than whatever the x value is at B. Now, because that's on the y-axis, at B, x is equal to 0. So these are all my x values less than equal to 0. This tiny little section in the middle here, so this tiny little bit here in between the y-axis and your x-intercept, that's not going to work because the graph is positive, the x value is positive. Positive times a positive doesn't work for me. However, here where I've got the yellow highlighting, here my x values are all positive because it's on the positive x-axis, but here my graph values are all negative. So everywhere between this x value here at 1 and this x value here at 3 will now be a product that is negative. Now, I can't include 3 because it's an asymptote, but I can include 1 because remember it said less than or equal to 0. At 1, A is at 1, 0. So it is then equal to 0 there, and I can include that. But I can't include 3 because this is an asymptote. Never include your asymptotes. Your graph doesn't exist there. And so what you need to do is you need to break down section by section your graph. Where is it positive? Where is it negative? And will that give me the product that I want? And like I say, 99% of the time, points of intersection and intercepts with your axes and asymptotes are going to be like the defining boundaries of these inequality answers. Does that make a bit more sense?
Yes, ma'am. Thank you.
Okay, good. Right, guys, like I said, I'm like by no means saying this is easy. This is not something that I'm like, oh, you should just get this. It's not easy. It took me a long time to understand these things. And quite frankly, the only way I can see these with any sort of accuracy is to draw my graphs. All right, and so if that helps you, draw away. All right, so this last question is something that you would have learned in grade 11, but it's also something that we test as like a complex question. So the question says, rewrite the equation of f in the standard form. So in the form that we're used to, a over x plus p plus q. So right now we know f of x is equal to, what was it, x minus 1 over x minus 3. That's what we know. We somehow need to get from there to that. So again, break down what you have. You currently have a single term. That fraction, x minus 1, x minus 3, is one single term. What we want is two terms. There's two terms here, fraction and q. Now there's a method, I suppose you can say, to do this. And all it is algebraic manipulation. So all it is understanding how algebra and values work in order to manipulate your equation. So first things first is if you compare what you have, this x plus p, let's actually do another color because we've already used yellow. So this x plus p in the denominator, we already have that expression. That's not something that we don't have. X plus p, we already have. We've already worked that out to be x minus 3. Now what we do in order to solve this is the following. We want to break our numerator up into essentially two terms so that we can separate the fraction and get the term a over x plus p and then the term q. So we know that our denominator is going to be x minus 3. That's not something in question. And I know in order for me to simplify to a constant, I would have to say x minus 3 divided by x minus 3. X minus 3 divided by x minus 3 is 1. Okay, so that gives me a constant term. However, if you look at your numerators, x minus 3 is definitely not the same thing as x minus 1. So what you now need to ask yourself is, what should I add or subtract to this negative 3 to make it negative 1? I would have to add 2. If you say minus 3 plus 2, you get negative 1. So you're manipulating your numerator to rewrite it in a slightly different format, but still mean the same thing. So in our numerator, we've got x minus 3 plus 2 over x minus 3 as your denominator. And now we separate this out. So we've got x minus 3 divided by x minus 3 plus 2 over x minus 3. This term is now my a over x plus p. And this x minus 3 divided by x minus 3 simplifies to give me my q term. And so what I have is 1 plus 2 over x minus 3. And if we just put that in the order we want it, we now have our hyperbola in its standard form. Right, so the key here is that you basically just need to manipulate your numerator to get two separate terms in order to get it in standard form. So in order to get the, sorry guys, I'm just trying to grab my charger. There's chaos here. In order to get it in the form a over x plus p minus q. It's just manipulation of the numerator. And I'm not saying that this gets asked often. It doesn't really. But we can expect you to go from the non-standard form of a hyperbola to a standard form. Okay, does that make sense? Lovely. Again, if it doesn't, just ask. But all you do is, so we're going to, okay, cool. We seem like we're all good. You're not, you just shot. Lovely, guys. Well done. Right, let's have a look at our next one. So this is now an example of a combination question. So remember I said, generally we start with just a basic hyperbola, then we go into a combination question, and then we go into our inverses. This is a combination type question. Like I say, 80-90% of the time, your combination question is parabola and straight line, but like we had here in 2019, it can be something else, parabola, hyperbola. Alrighty, so let's see what this has to say to us. The diagram below shows the graphs of f of x equals x squared minus 4x minus 11, and g of x is equal to f prime x, or the derivative of x. So this is now bringing in some calculus. It's not often that we bring in calculus into our functions questions, but remember, calculus is algebra. Any sort of algebraic expression can be represented as a graph. So this is working with the first derivative. Right, it then goes on to say A and B are the x-intercepts of f, and C is the x-intercept of g. D is the turning point of f. F and G intersect at m negative 1t and n 710. Okay, there was a whole bunch of words there that didn't really come out the way they should have, but we're fine. Okay, now, because it is a derivative function, there's a few things that we're going to have to remember. But what I want you to bear in mind is that because this is not a calculus question, you don't really have to use calculus except for finding the derivative if you need the equation of this graph. All right, so the focus here is not calculus, so don't let that throw you, but you can use calculus methods and knowledge in this question. So the first question says, calculate the coordinates of D. So who can tell me what is special about D? What is D to the graph of F? Nice, Lorato. Leila, nice. Kanin, Zalama, Simtanda, very nice, guys. Well done. It's a turning point. Now, we've already kind of discussed this and how you would do this. However, remember that if you want the turning point of your parabola, the way to find the x coordinate of your turning point is minus b over 2a. So the b and the a situation is from your original quadratic, ax squared plus bx plus c. And now we substitute in our values. So b is -4, so minus -4 divided by 2a, so divided by 2 times 1. This then gives me an x coordinate of my turning point of 2. And to get the y coordinate, what we do is we substitute this back into my original expression. So 2 squared minus 4 times 2 minus 11. Just chuck that into your calculator. There's no need to try and do that in your head, but that gives you -15. And so D is at 2, -15. Now, if you really wanted to, I'm going to be honest, this would never be my first choice, but if you feel that way inclined, you could also take your quadratic expression, you can complete the square. So remember, completing the square will give you the x minus p squared plus q, and the p and the q give you the turning point. Personally, I would never choose to complete the square, but if it's something you want to do, go for it. But otherwise, minus b over 2a, sub it back in, you have your coordinates. The second thing we're asked to do is determine the distance of CN. So this is a bit of an overlap with paper 2, because the distance of CN, because this is not a perfectly horizontal or vertical line, it's not even a line that I'm trying to draw here, we are going to have to use the distance formula. If it was a horizontal line, we could just count the x values or the difference in x values. If it was a vertical line, we could count the distance between the y values. But because this is a slanted line, we're going to have to use the distance formula. Now, you are given a formula sheet in both papers, so you will have the distance formula. And just bear in mind, every now and then there is a bit of overlap. It's not the end of the world, but just bear it in mind. Okay, now for the distance formula, you need 2 coordinates. We have n, but we do not have c, so that's a bit of a problem. Now, can someone tell me what is special about c on the straight line? What is c to the straight line? Nice, Leila. Lorato, nice. Good, guys. It's our x-intercept. It did also tell us that in the information. This is the x-intercept of g. X-intercept is where we would make y equal to 0, but obviously we need the equation of g. Now, we were told that g of x is equal to the first derivative of f. So we can find that derivative. That's easy. The first derivative of f, we just write f down, 4x squared. No, not 4x squared. I don't know what I'm talking about. X squared minus 4x minus 11. So we need to find the first derivative of this. Just use the trick. So remember, take the exponent, times it by the coefficient, and then minus 1 from your exponent. So this would be 2x minus 4. That is the equation of g of x. And now you can go and find your x-intercept. So 0 equals 2x minus 4. 2x is equal to positive 4. So x is equal to 2. So now you know that c is at 2, 0. And then you can just chuck it into your distance formula and work out Cn. Right, I see a question, so you guys can try that for me while I answer this. So, Nzalama, what's your question?
Ma'am, will I be correct if I assume that C, the x coordinate is 2, since if you cut the graph like in half, like it'll give you like the same coordinates as D in terms of the x?
Well done. Okay, good. So guys, that's another way you can do it if you don't want to go through this whole spiel. Exactly. Amazing. So what we should remember from our derivative functions is that this x coordinate of your turning point, as long as the straight line is the derivative, oh gosh, will be exactly the same as the x coordinate of your x-intercept. Those values are exactly the same. They are on the same vertical line. And that goes back to like points of inflection and so on. You can go back to your derivative functions. But absolutely, because g is the derivative of f, you are more than welcome to just take your x value of your turning point, and that translates directly to the x-intercept. Amazing, Zalama. Excellent. Okay, there's another question. Can we assume that C is the midpoint of MN? No. Unless they've told us it's the midpoint, or unless you've proven it somewhere, unfortunately, we can't. No. And Zalama, have you still got a question, or are you sorted?
No, ma'am, thank you.
Perfect. That was a really good connection. Well done. All right, so guys, I don't even know where we're at. We want the distance. So yeah, unfortunately, we can't assume that it's a midpoint unless we've been told that. And because we haven't, we do just have to use our distance formula. This is a formula that I hate. I can never remember the distance formula. But we would have 7 minus 2 squared plus 10 minus 0 squared. If your brackets are the other way around, it really doesn't matter. It's fine. And we end up with 5 root 5. You can leave it in third form. There's no need to write decimals. 5 root 5 is perfectly fine. All right, so this sort of brings in a bit of analytical. I think there is also a question. I don't know if it's this one. Somewhere. But every now and then we do chuck in a little analytical and graphs. It's nothing stressful, but just remember you do have your formula sheet. So if you forgot the distance formula, it is there for you. All right, so question B is now another lovely inequality, and we're going to approach it exactly the same way we did the last one. So this is asking where is, hang on, let me answer the question. No, so the question is, are you marked down if you change that 5 root 5 to a decimal? No, it's absolutely fine. There's no reason to, but no, we'll mark it right either way. Just then make sure your rounding is correct. All right, so this first inequality says where f of x is less than g of x. So f of x is your parabola. G of x is your straight line. So it's asking where is your parabola less than your straight line? And if we break that down even further, where does the parabola sit below your straight line? And now we go to our graphs. So we want where the parabola sits underneath the straight line. And so if we have a look at our graphs, it is sort of the bump of the parabola. All of this is below the straight line. Now remember, we're looking for values of x. And remember I said in the last question, oftentimes points of intersection, intercepts with your axes, are going to be the defining boundaries of these inequalities. So look at that. Point of intersection at M, point of intersection at N. Those are the two sort of boundary points of this inequality. So we know that the x value at M is -1 and the x value at N is 7. We just chuck that in. Always write it from smallest to biggest. So -1, 7. Put the x in the middle and fill in your inequality. Your inequality will always be one inequality like this if it is a continuous section of your graph, unlike what we had earlier, where we had 2 disjointed sections of our graph, we then had 2 different inequalities. So if it's a one continuous section, it will be one inequality, 2 disjointed sections, 2 different inequalities. We're not going to have equals to, because go back to original inequality. It doesn't say where f of x is less than or equal to. It just says less than. Right, if you want to write it with the brackets, sorry, I never write my answers with brackets, so thank you for reminding me. We would say x is an element of, so x will be these values. Because we don't include the -1 and the 7, we use round brackets. And again, start with the smallest up to the biggest. That's it. Right, so I prefer inequality answer, but if you prefer interval notation, again, it's absolutely fine. You are not going to be marked wrong either way. We all good so far? Lovely. Okay, question. Do we get marked down if we don't include the word units next to our final distance value? No. We don't really care about units in maths. It's a bit of a pet peeve of mine because I think we should, but no, you won't get marked down. It's the same as you don't get marked down. Oh, so if, say, for example, in I, so AI over here, where it said the coordinates of D, we won't actually mark you down if you don't write your answer as a coordinate. As long as I can see that you have worked out X and you've worked out Y, we're not super pedantic about it, but it does say coordinates. So write down the coordinates. But no, we don't care about units. Don't stress about that. Other question, ma'am, when do we include or not include the numbers? So if we jump back to this inequality, we would only include the numbers if the inequality sign had the equals underneath it. So in this last question that we had here, the inequality sign had less than or equal to. So that's why we could include the 0 and we could include the 1. The only time you won't include it when there is an equal sign is if there's an asymptote like we had here. But always go back to your original inequality. Because this inequality didn't have the equal sign, I don't include them. But if it had been less than or equal to, then I would put the equal sign with my inequality, or I would use square brackets if I was going to use the bracket form of my answer. But that's how you tell. Go back to the original. All right. B2 says, determine which values of x where g of x minus f of x is a maximum. Okay, so again, they've been a little bit mean here and they're throwing in some calculus. Who can remember what it means if we are looking for a maximum value in the context of calculus? Okay, apparently we've got a weird little rectangle going on there. What do we do if we're looking to maximize or minimize? Okay, we've got some suggestions. Both of them are correct. So Lebo has said derivative. Nzlama has said highest turning point. Navashni has said first derivative and equate to 0. So kind of combining labels. Both of them are fine. I'll actually show you how to do both so you can see it doesn't matter. And again, why, even though this sort of implies or leans towards calculus, you don't have to use calculus. I do think calculus is the easier option here, but I will show you both so that you can see how you would deal with it. Right, so where it is a maximum. So basically where the distance, and remember, it's always top minus bottom. So in this case, because they've mentioned g of x first, they're basically talking about the distance between m and n being a maximum. So somewhere here, we will have a maximum distance between straight line and parabola. We don't know where it is, but somewhere there. Okay, so first things first is we actually want to go and substitute into this little expression. So g of x we know is 2x minus 4 minus f of x. And guys, please put a bracket there. I know it seems so silly, but you have to remember to distribute in your negative. So minus x squared minus 4x minus 11. This will be the distance between g of x and f of x. Distribute in your negative and simplify. So this would be 2x minus 4 minus x squared plus 4x plus 11. Obviously, if you can simplify straight away, that's absolutely fine. And so we end up with an expression of minus x squared plus 6x plus 7. Panic. That gives me the distance between g of x and f of x. Right, so like I say, you've got two options. If you want to go the calculus route, it's exactly what we said earlier. You find the first derivative, you make it equal to 0. So we want this derivative in terms of x of my distance. and that would be minus 2x plus 6. That is the derivative. We now make that equal to 0, and we solve for x. So 6 is equal to 2x, therefore x is equal to 3. And it just said the value of x. That I didn't need anything more than that. It didn't say what is the maximum distance. It just said determine the value of x, and this would be your calculus route. Personally, I think because we have the calculus option, it is a little easier, but you don't have to do it like that. So Nzalama said your highest turning point. So I'm not going to do all of this calculation again. We already know that the expression for our distance is minus x squared plus 6x plus 7. Now, what I want you to understand is that even though this represents a parabola, the expression represents distance. And so we know that the maximum point of a parabola is its turning point. So if we can figure out in terms of this expression where the turning point is, we have got the value of x where my distance is a maximum. And so we use our little turning point formula, minus b over 2a. This would be minus 6 over 2 times negative 1. Negative 6 divided by negative 2 is 3. Exactly the same answer. So how you choose to do it is completely up to you. Personally, I'd probably go calculus route just because I do think it's slightly easier. However, it doesn't matter. Both of these will give you the full 4 marks. It doesn't matter what you choose to use. And so as long as you understand what you're doing or you've made a choice based on your preference, you do you. So like I say, every now and then we chuck in some analytical geometry and some calculus into our functions questions, even though analytical is paper 2 and calculus gets its own set of questions. But we can put those questions in and we need to be able to deal with them. So there's 2 options here for you. You decide. Okay, whatever makes sense for you. Okay, I'm just gonna, I also realized I didn't let you take screenshots of this first question, and that was a my bad situation. Right, so here's our first question. Let's take screenshots of this. I will go to the next question now. Obviously, if you've got questions, guys, just let me know. Okay, and this is the second question that we've just done. This was a really nice question. I really like this question. I know that sounds a bit weird to like a maths question, but this was just a really nice question in terms of it was a slightly trickier question because of the calculus and the analytical, but as long as you know your stuff, it's pretty straightforward. All right, so guys, we've got 8 minutes left. We are not going to get through this whole question, but that's also fine. And so what I'm going to do is I'm going to let you take, I'm doing well in life. I'm going to let you take a screenshot of this, even though you can quite easily find this online. And I'm going to let you we'll try and do a few of these questions now, see how far we get. Oh, I was optimistic in how much space I needed here. Still too optimistic. Okay. Right, so let's screenshot this. You can give it a try. What I will do is on Wednesday, I'll put the answers up for all of these questions so you can see. But let's see how much we get done now, and then you can finish it off. All right, so this is from 2019. So what year are we in? 2024. So from 5 years ago. Okay, so it's relatively old. But a nice question because it just shows you that it doesn't always have to be a parabola in a straight line. So we've got the graphs of f of x, which is equal to x squared plus bx minus 3, and g of x is equal to a over x plus p. Couple things to take note of. I know that the a value here is 1 because I haven't put a variable in front of the x squared, and it's just x squared. A is equal to 1. You don't need to go and work that out. You can assume with 100% certainty it's 1. The next thing I want you to take note of is that in terms of your hyperbola, It has definitely shifted left or right, and we can see from the hyperbola that it shifted to the right, but it has not shifted up or down. There is no plus q value. So there's been no vertical shift. It then goes on to tell us that f is a turning point at C and passes through the x-axis at 1, 0. That's really nice because that's also where our asymptote is. D is the y-intercept of both the parabola and the hyperbola, and the graphs of f and g also intersect each other at E and J. The vertical asymptote of g passes through the x-intercept of f, and we can see that with the dotted line. All right, so the first question says, write down the value of p. Now, I want you to go back to literally the first question that we did. Take note of how the hyperbola has shifted, left or right, and think about what your expression should look like. So that denominator, to represent a shift of 1 unit to the right, and we can see this has gone 1 unit right. What should that denominator say? So this denominator, what should it say to represent a shift 1 unit to the right? Nice, Lorato. On it. Do we agree? Salama, nice, guys. Excellent. Good, 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 good. Right, so we know that it should read x minus 1, which means that p is equal to -1. Think back, what should you substitute in order to get x minus 1? We must substitute in a -1. Right, the next question says show that, and I cannot stress this enough, and I know at a matric level you've probably heard this a million times. The second you have a question that says show that, please do not use these values. Pretend the question says determine the equation. If you use any of these values that I've given you in your working out, you are not going to get any marks. So let's establish where A and B are. So A is the numerator of your hyperbola. B is the coefficient in your quadratic equation to x. Now you can start with whichever one you want. It's completely up to you. Like I said, completely up to you. Let's start with A because that's nice and alphabetical. Why not? We already know that g of x is equal to a over, and we've got this denominator, x minus 1. Now go back to what I said earlier. If you have got only one unknown, substitute a point that you know your graph passes through, and you solve for your unknown. Now this is your hyperbola, so we need to find a point that this hyperbola passes through, and we can see that this hyperbola passes through the point D. And who can tell me what is special about the point D? Anzalama?
Ma'am, it is the y-intercept
Of which graph?
of the hyperbola.
And the parabola. Do you agree?
Yes.
Okay, good. So guys, that's really important. It's the y-intercept of both. Now, if you go to your f of x equation, you know what the y-intercept is. Remember, the c value is your y-intercept. So you know this is at 0, -3. So we can substitute in point D, and we can solve for a. So -3 is equal to a over 0 minus 1, which is -3 is equal to -a. That's a weird looking -a. I'm sorry. Let's try that again. -a. And so a is equal to 3. The only time I should see a equals 3 is in your answer. So we have confirmed that that's correct. Now we're going to use the same logic for b. We know that b is in your hyperbola. F of x is equal to x squared plus bx minus 3. You only have b that you're looking for. So substitute in a point that is on your graph. Now, we're not going to substitute in D because remember, all that's going to do is cancel out everything. Because if you substitute in x equals 0, b times 0 is 0. So you actually cancel out the b, which is not what we want. But we know that the parabola has an x-intercept at 1. So we're going to substitute in 1, 0. 0 is equal to 1 squared plus b times 1 minus 3, which means that 0 is equal to b minus 2. And so b is equal to 2. Again, only time I should see b equals 2 is in your answer. We have now confirmed that that is true. So guys, when you get to show that question or prove that question, use information that you have been given on the diagram or in the information of your question to answer it. Do not use the information given to you in that specific question. Otherwise, you're going to get 0. Zlama, is your hand still up? Do you still have a question?
No, ma'am.
Cool.